Welcome to the Earth Science Classroom. Welcome back. So this video is on tides. It's part 2. It follows on from part 1, obviously. And part 1, we discussed basically what tides were, the rise and fall of the ocean sea level and the surface, and basically what is causing them. And this video is all about what creates the tidal cycle on the Earth and what patterns and or parts of the cycle there are, so the different patterns that arise from the Earth, Sun, and Moon system. And then obviously where you are on the planet. So location is very important because you might have a certain type of pattern, tidal pattern in a certain location, but you might go on vacation or go somewhere else or move somewhere else to a different part of the world. You have a completely different cycle in the tides. So location is very important. All right, join me now. All right, so what creates tidal cycle? So let's first just review video 1 or part 1. Review part 1. Here we go. So we know tides affect the oceans. They also affect the lakes in a small amount. And in a very, very small amount, they also affect the physical land as well. But that's very, very, very small fluctuations, and it's very hard to detect because you have other things that go on land as well, like the vibrations from earthquakes and tectonics and plate movements. But the oceans are the main area where we study tides, and we can see tides and we can observe tides. And tides are the rise and fall of the sea level caused by gravitational pull of the moon, mostly, which moon, not moon, moon. Let's say 100% of the moon, and then the sun, even though it's really large and has large gravity, equates to about 46% of what the moon's effect is on the Earth's oceans. And this creates it's going to call the Earth right here. And let's say this, the sun is this direction, and then let's say the moon is over here. That what you'll have is you'll have these tidal bulges, which bulge towards the sun and the moon and pull the water towards these celestial bodies. So the bulge would account for the high tide, and the areas where there's less bulge would be the areas of low tide. So that's the basics. So the tidal cycle is pretty much revolves around the moon's revolution around us, the Earth. That's caused by the Earth's gravity holding the moon in position in space, basically. Now, the revolution is the one complete orbit around the Earth. Okay, we call this revolution. So this word right here. And as it moves and goes around the Earth, now this takes a certain amount of time. At the same time, the moon and the Earth are both rotating on their respective axes. So the moon rotates and also the Earth rotates. So it takes the moon 29.5 days to revolve around the Earth. And the rotation is the same time, 29.5 days. Same time to rotate on the moon. So basically one day, one lunar day is the same as one lunar revolution or one lunar year around the Earth. And as the moon is going to revolve around the Earth, the gravitational pull of the moon, thanks to Mr. Newton, okay, 1687, fourth law, and it's inverse based on distance. So the closer the object is to each other, so object 1, object 2, and their masses, the closer they are, the stronger the gravity. So as the moon revolves around, so does the tidal bulge move around, and you get the periods of high tide, which is bulge, and periods of low tide. And those periods again come back to time. So a matter of hours, you could have a matter of hours of low tide, and then it will change and slowly start to move towards high tide and have some time or duration as high tide. Now, these coastlines, beaches can obviously differ, and we'll get to that later on, but principally you get high tide, then low tide, and it's a big cycle. Why? Because it is caused by the moon and it's constantly revolving around the Earth and pulling the water. Now, the sun is more of a consistent tidal effect. You do have the tidal part of the solar tidal part, and you have the lunar. So you have the solar tide, which is more consistent because the sun is in a constant position in relative to the Earth, and we do obviously orbit the sun, but the distance is pretty much consistent. There is a point where the Earth is closest to the sun versus furthest from the sun because our orbit is slightly elliptical, but the tide from the solar is pretty consistent. Whereas the lunar tide, which is the largest component, or has most impact, does also change because the moon's closer, has more effect, and the moon's going to revolve around the Earth as well. So we do get our periods of high tide and low tide. High and low tides. And these are pretty generic. And they cycle, and there's a pattern, okay? And they fluctuate. The ocean fluctuations, low and high tide. Now, there are periods where you get an alignment or a positioning where the sun and the moon are in the same position, like they are aligned, okay, astronomically. So the power of the gravity, when they are aligned in a straight line, is greater. And the periods of very strong gravity is going to have a larger effect on the tides, and we call these spring tides. So it's the largest effect on the tides. So the range or the height of the tides. And again, that can correspond to increased amounts of erosion, maybe transportation, tidal current, and the landforms that are created by these tides, actually the strong tides. So spring tides means to bounce up, okay, and that happens when these are aligned. Now the next situation is, obviously we have the Earth. Now we have the moon up here. And we still have the sun in the same position relative to the Earth. Now, here we have the sun's gravitational pull. Okay, so we have the solar tide like that. And we have the inertia on the other side, the two bulges. But also you have the moon at a 90-degree angle. Okay, or it's not aligned. It could be, here or here, but obvious reasons we're going to put a 90-degree angle here. So the moon's effect is also going to pull the water towards that, and there'll be a bulge down here too. So what you get is a more averaged out, a less intense, less extreme tides that we call neap tides. Now the word neap comes from the origin of barely touching, or a small amount. So Neap tides and spring tides are all based on where the moon is relative to the Earth and the Sun. If they're aligned, it's going to be a stronger tide in spring. If it's going to be at a different angle, it's going to be neap tides. And obviously, in between the times during each month where the moon is orbiting or revolving, in between you get the general high tides and low tides. But there's a pattern, high and low, and then at certain times during each month you get these moon positions that will cause either a spring tide or a neap tide. So beyond the cycle, which is created by the sun and obviously the moon's revolution around the Earth, beyond that you get patterns. Patterns of how many times per day do certain areas, certain locations experience high and low tide. So you could be in California, you could be in Argentina, you could be in New Zealand, you could be in east coast of China versus Siberia. And the ocean water is going to act differently, okay? Now, these patterns are pretty straightforward. We get diurnal, okay, which means day, okay? We get semi or semi-diurnal, okay, again, so semi means two, okay, or double, all right? And you also get mixed. Now, mixed could be more semi-diurnal, or it could just be diurnal, but mixed means that there is a range in high tide heights. So how high the high tide goes. Okay, now, so the first one is diurnal. Again, diurnal means day. So what we have here is time in hours, starting from 0, and I'll just get 12-hour intervals, so 12, 24. So it basically goes over a certain amount of days, right? So it rotates through or cycles through days. And on the y-axis, we have the height of the tides in meters. So, okay, if you're American or European, okay, 12 different ways. But the height, I just use 1 meter as a generic number. Okay, so it's going to be increase by 1 meter or decrease by miles. So this is generally going to be the high tide mark and the low tide range. Okay. Now, again, this is very generic. I haven't done it for a certain location. And obviously, these ranges and heights in meters can vary tremendously from a few centimeters in, let's say, the Gulf of Mexico, which is very enclosed bay and gulf, to the Bay of Fundy, which can be up to 17 meters in tidal range, which is insane. So, as you see here, starting off here, we're going to experience high tide, okay, after basically 12 hours. So 1 high tide, and then there's 1 low tide. So there's 1 high tide with diurnal, and there's 1 low tide. Okay, so you get 1 each. So it's a 12-hour difference. Okay, so 12 hours difference. Actually, in accuracy, it's 12 hours and 46 minutes. Now, why is this? Well, it takes an extra around 50 minutes for the Earth to catch up the moon. So as the Earth rotates on its axis, it takes 50 more minutes of rotation for the Earth to come back to the same, make 1 revolution according to where the moon is. Because the moon, 29.5 days to rotate, sorry, revolve around the Earth. So as the Earth is spinning on the axis or rotating, the moon's also moving. So the Earth is going the same direction. So the Earth needs 50 more minutes each day to catch up with the moon. And this is called a tidal day. Next one is semi-diurnal. Again, so we got 2 and day. All right, caused by the rotation and movement of the moon plus the sun as well. Okay, so in this one, obviously you see the same thing, the height in meters, 1 and -1. And what you have is, again, we're starting at 0 time and goes through the different days. And goes through the days and cycles through the days. Now we've got, as you can see here, we've got within the first 12 hours, it goes up to be a high tide and comes straight back down to be a low tide. And it's going to repeat. So again, after about 6 hours, okay, it's going to be high tide, and another 6 hours low tide. So within one 24-hour day, you've got 2 high tides, you've got 2 low tides. So you've got a let's say a faster cycle through one 24-hour day where you're experiencing 2 lows and 2 high tides. So the ocean sea level is going to move pretty quickly over the course of around 6 hours. Now that's going to change, of course, because of tidal day, but you've got a lot quicker movement of the ocean in relative to the beach, and then that's going to obviously have different impacts on the features of the beach, the intertidal zone of the beach, the processes, when you compare it to just a diurnal, which has just 1 high and 1 low tide per 24 hours. All right, so the last pattern of tides is called mixed. Now, obviously, mixed, you're going to have, it's not as rhythmic. So the rhythmia is going to change. It's going to be more, let's say, random. And if you're based on even an individual beach or locations variables. So mixed is pretty much the low tide. Okay, again, we've got the same thing, -1 and +1, and the height in meters and the time going through the days. Now, what you see is you have a high tide right here. You have a low tide right here, a high and a low. So in this instance, we have 2 high tides, and we have 2 low tides for every 24 hours. So this would be a mixed semi-diurnal example. And the mixed comes in where the high tide, as you can see, the high tide is all at different heights. So it could be cyclic over a long period of time, but within, let's say, 2 days, so from here to here, 2 days, you've got 3 or 4 different tide heights when it's high tide. So this would obviously have a large impact on the intertidal zone, have a large impact on erosion, and also transportation and deposition. So sediment could be deposited when, let's say, it's a higher tide, or it could cause more of a beach cusp, or it could cause more sandbars, or more troughs, or more rips on certain times when the tide is higher or lower. Also change the surf conditions based on when it is. So these are more complex to figure out, but they are awesome to see because you've got the beach having to adapt to these different tides and, of course, tidal ranges. Now, speaking of different tidal ranges and different locations based on variables, you have the difference in height between high tide mark and the low tide mark. This is called a tidal range. As you can see by this outline, Davidson 64 basically did 3 different categories. Okay, so a beach would fall into these 3. Now, the microtidal is less than 2 meters. All right. The meso or middle tidal range is 2 to 4, and anything above 4 will be classified as macro. Now, there's a lot of beaches that would fall under macro, and meso would be a small amount. So Hayes in 79 kind of added some more categories to it and had 5 categories to further develop the separation or differentiation between each of the tides. So we looked at micro being less than 1 meter, so it's kind of a similar thing as Davis, but he separated the meso into 2, low and high meso, low being 1 to 2 meters and high being 2 to 3.5 meters, which is more like easier to differentiate than 2 to 4. And then low macro would be 3 to 5.5 meters, which is again a lot of beaches. But there's also a couple that fall under the large macro, which is 0.5. As I said before, the Bay of Fundy, which is in Canada, has reportedly the largest tidal range, okay, at 17 meters, which is insane. All right, so thanks for watching the video. We'll get on to tides number 3 in terms of locations and the variables. And thanks for watching, guys.